Next, we're given a new set of functions to work with, several of them, okay? And so we're going to have m of x, we're going to have n of x, we're going to be working with p of x, maybe, yeah, we will actually. There's also q of x and r of x. Luckily, I have enough colors for all of these. So this one says, on this set of examples, find the indicated function and write the domain in interval notation. Q composition P of x. Y'all, that's a new function that we're forming. Remember how we write that, okay? We're going to first of all rewrite that as Q, the outer function, evaluated at P of x, the inner function. That is so important that you write that. Okay? Now, there's really nothing to do inside other than to replace P of x with what it is equal to. So we're going to do Q evaluated at P of x is x squared minus 9x. Okay? Now, when we go to our Q function and evaluate that at the blue stuff that we're supposed to be putting in there, okay, for us, that's going to look like 1 all over, okay, it's our variable here, minus 10. But now we are replacing x with x squared minus 9x, right? So if we clean this up just a little bit, Q composition P of x, or simply Q composition P, means the same thing. That's going to be 1 all over x squared minus 9x minus 10. That's the new function we created. Now they want us to discuss what is the domain of the function. Okay? So we have to exclude values for the domain of Q composition P. That would, in this case, give us 0 in the denominator. And then we've also got to look at our inner function's domain, the P of x. First of all, excluding values from our domain that give us 0 in the denominator, I'm going to see what x squared minus 9x minus 10, what values of x would give me 0 in that denominator. So set that equal to 0 and we'll solve. All right, for this particular quadratic equation, it will be factorable, don't you agree? Setting each factor equal to 0, then solving for x. We'll get x is equal to 10, and x is equal to negative 1. Those guys give us 0 in the denominator of our fraction. They are not in our domain. They are uninvited to the party. Okay? Now, for the next thing to consider on the domain of a composition function is what is the domain of the inner function. In this case, it is P of x. Since P of x is equal to x squared minus 9x, and that will give us no values of x that will yield 0 in the denominator or negative under a square root, its domain is all reals, so really all we have to do is exclude negative 1 and positive 10. If we're writing everything in our domain but negative 1 and 10, the way that we accomplish that in interval notation is we say everything from negative infinity up to the smaller value of negative 1, union with stuff in between negative 1 and 10, union with values of x that are bigger than 10, greater than 10. And so that sums up all of the elements in our domain. It's basically everything except for negative 1 and positive 10. All right? On number 72, we are going to be, okay, doing Q composition M evaluated at x. So the outer function is the Q function. The inner function is M of x. That is purple for me anyway. Okay? Very important first step. Now you work from the inside out. So now I need to figure out what is going to be my Q function evaluated at m of x, which is the square root of x plus 8. Okay? So, what that means now is to come to your q function and replace the x with square root of x plus 8. Okay? So this is going to look like, for our q function, it's 1 all over x minus 10, but instead of having an x, I'm going to be replacing that with square root of x plus 8. Let's clean this up just a little bit, okay? And we will say that q composition m is equal to 1 all over the square root of x plus 8 minus 10. Okay? Now, this one's kind of an exciting one to talk about the domain of the function. Remember, not only are we going to discuss what values of x should be excluded for this composition function, q composition m, but we also have to look at what needs to be excluded from just m. You know, okay, so yeah, we're going to hit it at the same place down here for our domain errors or issues. Okay? First of all, we can't have values of x that will give us 0 in the denominator of a fraction. Okay? So if I kind of get off the side of my paper and I'm trying to look and inspect those values, it's going to be the values of x where the denominator is equal to 0. Those things need to be excluded from the domain. Anything that gives the denominator of a fraction equal to 0, that's not good, okay? First thing I'm going to do is add 10 to both sides. Now I've got a radical equation, so to solve that, I'm going to square both sides. All right, and that'll just leave us with x plus 8 equals 100. So x is equal to 92 when we subtract 8 from both sides. So if you can think about that, if x is equal to 92, we've got the square root of 100 minus 10, also known as 10 minus 10, and that will give us 0 in the denominator. So, yep, 92, you're a bad value. You're out of here. Also, since we have, move him out of the way, there we go. Also, since we have a radical, a square root, we want to make sure that that radicand, the x plus 8 quantity, stays greater than or equal to 0, because the second thing we look at for domain is to ensure that no values of x will yield a negative under an even indexed radical. So when we solve this inequality for x, as long as x values stay greater than or equal to a negative 8, we're good. Okay? So to sum all this up so that we can actually fill out what is the domain in interval notation, maybe what we want to do is kind of organize some stuff. Okay? First of all, 92, nope, not you. Okay? And then for this part of it, x values need to stay greater than or equal to a negative 8. That's going to be everything greater than or equal to a negative 8, but not 92. All right? And I kind of have a big gap in there, and I really shouldn't. It should be kind of snug right up there to the 92. But when we go to write our domain in interval notation, read your number line from left to right, and it's going to be bracket. Ooh, I don't want that fat number, or that fat pen there. Bracket, negative 8, comma, up to 92, not including 92, so parenthesis, union with parenthesis, stuff bigger than 92, so 92 to positive infinity. There's my domain in interval notation. Now, I kind of didn't point out right here that don't forget you also have to look at what is the domain of this inner function, the m So if we look at m, again, it's going to be the same thing because we want to say x plus 8 has to be greater than or equal to 0 for that radical. So x values need to stay greater than or equal to -8, and we've already taken care of that. One thing that I want you to notice is that even though q of x right here, even though q of x makes up part of our composition of our function, it's the outer function. And for q of x, x can't be equal to 10. 10, though, is in our domain. All right? Because after we first process input values for m, 10 is okay for m of x. So once it reaches this 1 over the square root of 10 plus 8 minus 10, we do have a real number and not 0 in the denominator. So notice that 10 is in the domain of this function.